Okay, we're looking at number section 3.5, number 32, and they want you to find a general form for f of x equals x plus 2 to the negative 1. And on this problem, what you kind of have to recognize is, and because we learned the chain rule in section 3.7, but the derivative of the inside of this function, the derivative of this linear function is just going to be 1. So this is very similar actually to number 31, or if you were just to consider f of x equals x to the negative 1, but you just have x plus 2 instead of x to the negative 1. Now, that's not always the case. If this had been a more exciting function inside here besides just a linear function, you would have to use a chain rule to take the derivative of the inside as well. So let's just practice a couple of the derivatives. Let's see, we bring negative 1 down, x plus 2 to the negative 1 minus 1, which is negative 2. The second derivative, and normally the chain rule would require you to take the derivative of the inside, but the derivative of x plus 2 is just 1. So we don't have to keep doing that. Right now, the second derivative, negative 1 times negative 2, and x plus 2 to the negative 3. So that's positive 2, x plus 2 to the negative 3. Now, the fourth derivative, or the, third derivative, is going to be negative 1 times negative 2 times negative 3, and then it's x plus 2 to the negative 4, and that's, of course, positive 6 times x plus 2 to the negative 4. So the pattern you should see coming out is that, first of all, let's see, I didn't put my negative here. This function is going to alternate between negatives and positives, and when you have an odd derivative, you're going to have a negative sign on your derivative. So the nth derivative, you can alternate the sign by just doing negative 1 to the nth power, and that's going to handle it, because if n is 2, say, then negative 1 squared will be positive, and so that will be like positive 2, like you have right there. But if n were 3, negative 1 to the third power, of course, is negative, which will ensure the negatives there. So when you have odd derivatives, you'll have negatives, and when you have even derivatives, you'll have positive numbers. Now, you'll notice that on the third derivative, you had 3, 2, 1. On the second derivative, you had 2 times 1. On the fourth derivative, you'll have 4 times 3 times 2 times 1. So we learned that that is n factorial. And then we have this x plus 2, and then we are one more, so we have the negative of n plus 1. So that's how we get to the negative 4. So that is the pattern for this problem.